Hi there. So I want to share something interesting I've been working on. About 4 months ago, I ran into this video from Microsoft developers about the integration of generative AI into the Power BI platform product. It gave a general overview of how the Microsoft team has been able to integrate generative AI functionality into Power BI. And what piqued my interest was the last presentation, which introduced Power Virtual Agents. And these Power Virtual Agents are simply the marriage of uh, basic chatbots powered by generative AI with the execution of actions, meaning you can chat with the bot, tell it exactly what you want to be done, and it will be able to complete those tasks for you. Though it seems trivial, this is a pretty powerful capability that we can decide to give generative AI access to. And exploring the different ways this can be done led me to my current project. But before getting into that, listening to the full presentation would give will help you understand the functionality and the features that I'm trying to build.
Experience. And this is something that I can't wait to invite Kendra on stage to go through and show what's possible, what they built, and even more importantly, how they built it. Take it away, Kendra.
Thank you so much, Charles. Hey, everyone. Bots typically do two things: answer questions and complete tasks for their users. And I am so excited to show you how with generative AI in Power Virtual Agents, we can enable them to do both without manually authoring a single conversation, which can result in some pretty amazing bot experiences like this one. We'll jump ahead. We were going to show you the cake and then we were going to show you how we were going to make the cake, but we're just going to wait to unveil the cake till the very end. So we're going to jump ahead. So I'm going to go ahead and get started and show you just how easily it is to get started building the bots that Charles spoke about with generative answers. So from right here within the AI capabilities page, I can easily point my bot to a number of different knowledge sources, such as the Holland America website or other internal proprietary knowledge sources like Agent Manual or SharePoint. I can also control how the bot behaves within the advanced AI configuration settings. And with just a few clicks, my bot is immediately configuration settings. And with just a few clicks, my bot is immediately able to have rich conversations over these data sources. So this will be my first cruise, and I'm not really sure which travel documents I need to bring with me. And just like that, I'm able to see exactly which documents I need to board the cruise, as well as some helpful links to where I can find this information on the website. Better yet though, these conversations can now have multiple turns while maintaining the conversation context. And if I wanted to, I could go ahead and publish this bot to my website or a number of other channels such as Facebook or Teams. We know though that simply providing information is not enough when our customers are coming to our bots for help. We also need to be able to take action on their behalf. For example, retrieving a reservation status by calling a backend API. Now, typically, you would need to build every single one of these topics within Power Virtual Agents, state-of-the-art, low-code authoring canvas, which just went GA yesterday. And this is assisted with Copilot, of course. But with the new GPT-powered conversation engine, this process can be entirely transformed. Your bot now has a library of different plugins that function like Lego blocks that it can self-assemble in order to fulfill the user's request. And where any required information is missing, it can actually generate the question to gather this from the customer. These plugins include enterprise APIs or any of the thousands of pre-built Power Platform connectors. They include Power Automate flows and, of course, bot topics. So if you have actually built a bot and you're sitting in the audience right now and you have spent months and months testing and refining and iterating and testing again and writing lines and lines of code, I know that this sounds like a fairy tale, but it's not, and I'm going to show you. So remember, all I've done is point my bot to a couple of Holland America APIs and added one pre-built weather connector. I have built no manual topics by hand. Now, in order to get started testing, so you can see this in action, I'm going to go ahead and open up our new tracing mode so you can see these plugins automatically chain together in real time and follow the conversation in the test chat on the left. Now, I'm curious, what last-minute cruise options are available to the Bahamas next week, and what's the weather there like right now? I'm a habitual overpacker, so I'm really hoping this can help me. Sometimes hitting enter is the hardest part of these demos. And just like that, GPT is able to parse my request and understand that it can fulfill it with a combination of a call to a reservation system with a custom connector action plugin and a pre-built weather connector plugin. And again, throughout this, thank you. I was gonna signal the applause later, but I love the enthusiasm. So yes, keep it going. It only gets better. Along the way, you're able to follow the system's thoughts and observations to understand how the large language model decided what to do next. Now, the bot was able to identify the input for destination and time were fulfilled and return the weather portion of the question here. Remember, I don't know what is the weather topic, right? It also recognized that the departure port required input to be able to return the cruise options is missing and actually generated that question to gather the information from me. So I think I'll depart from Miami. And amazingly, it extracted the entity Miami to fill the missing input slot and execute the call to the reservation system to provide last-minute cruises from Miami to the Bahamas next week. This is where you applaud. Now that was pretty awesome, but I don't know about you. This Rotterdam ship or cruise looks pretty incredible to have available. GPT parses my request and understands that it can fulfill it with another custom connector action plugin and automatically chains it up to continue the conversation to return for me the cabin options for the Rotterdam cruise. All we did was give our bot access to a set of existing APIs and plugins. We built no manual topics by hand. The bot was able to self-assemble and chain together a combination of actions and APIs in order to fulfill the requests. And where any information was missing, it actually generated the questions to gather that information from me. Between this and chatting over company-specific information, we know this is going to revolutionize bot building as we know it.
So it took me a while to get started, about 3 months to be exact. So I didn't exactly start working on the project right away. But what pushed me to start was was watching the browser company introduce some new features into the app browser. And in that video, like the CEO explained like all the challenges they had to deal with while trying to integrate artificial intelligence tools into the browser, and how everyone was asking for features, for AI features in their browser, and everyone was saying how the browser would be dead and yeah, all that stuff if it didn't have those AI features. Then the video goes on to say how they decided to introduce those features into their browser bit by bit without having to compromise the user's current flow. So basically, there are little snippets of AI placed around the browser, from like renaming like really long download names to making shorter tab names, or having AI ready when you hit Control F and you want to scan through the current page you're on, or when you hover over a link and you get a quick preview of the contents of that the page that link goes to. So these were small incremental features added in, and they're just like snippets, not changing any of your previous workflows. They're just there in case you really need them, and we don't, and they don't have to overwhelm users with like an entirely new interface. They just stick to the interface they already have, and then introduce these snippets of AI around that makes the user's life a little easier.
Well, and thank you for tuning in. It's so awesome you all are here with us.
There's a lot to talk about, but first let's start with your competitors. You've been falling a bit behind. What do you attribute that to?
Starting with the tough questions. To be honest, we've been prototyping AI features since January. Our team has built over 30 AI-powered features this year. But what we found is the technology at times was unreliable, it was expensive, it was slow. And along the way, we kept seeing AI launch after AI launch that promised the world. It promised the future, it promised transformation, and we just time and time again got a little bit let down by the hype. And so we were skeptical. We are a bit skeptical. But at the end of the day, at the browser company, we are optimists, and we do believe this technology is real. So we did what we always do best. We just try to have fun with it and build the internet that we want for ourselves and we want for our members. And so today, we are so excited to announce Arc Max. It is a bundle of starting with 5 AI-powered features that we hope makes your day on the internet just a little bit faster, just a little bit easier. The small moments, a little bit less internet.
Well, it seems like we have a lot to talk about, but before we get in too deep, here's a short segment from our sister company, BCTV QVC, who got early access to Arc's newest AI features, Arc Max. Folks at home, if you have any questions, please include them in the chat, and we'll be right back.
Once everything's perfectly organized, I'll start working on my thesis.
I got a new feature for you, 5-second previews. Say you're in between meetings and quickly need to decide where you want to eat dinner tonight.
That happens all the time.
All the time. With this first Arc Max feature, all you have to do is hover. And just like that, in 5 seconds, we've got a preview. It tells you everything you need to know.
Would you look at that?
About the restaurant. There's no reading, there's no scrolling, there's no being pestered to join a waiting list or newsletter or looking at ads or anything like that.
Just hover. Who knew it completely processes the information for me? I don't have to do a thing.
You don't have to do a thing with Arc Max. So you might be wondering, can I get more? Well, let me show you one of my favorite features. It's called Tidy Tab Titles.
Say that 5 times fast.
I can't, but I can show you 5 times fast. Let's say that you're shopping for an iPhone accessory.
I do that all the time.
Got to accessorize. So here's what it would look like in Chrome.
Well, it's just so many tabs. I can't read anything. It's too much internet.
It's too much internet. You can't read anything. All the tabs are the same. It's total nonsense. Well, Abby, with tidy tab titles, no more.
No more.
Watch this. I'm gonna take this title with this tab with this big long name, and I'm gonna drag it into my pin section. And just like that, Arc is gonna rename it.
Look at
Short,
Look at that.
4 words or less.
It's like magic.
Super concise.
Well, can it do more? Does it work every time?
It works on anything. Here's this article. You know, it's a woman suing McDonald's because the coffee.
She's suing again?
She's suing again. Coffee was too cold this time. And let's take a look here. So normally in your browser, you might use Command F to search. And of course that works, but searching on a page is pretty terrible. So what if you could just ask it anything? Like, is this woman in the right for suing McDonald's? And I type in the question. Look at that.
Oh my god.
So not only will it answer our question for us right there, but it will also pull out a little excerpt, and you can click find on page and it'll take you right there, and it'll show you the exact part of the article that answers your question.
Goodness. Talk about years back.
Years back from your life. So much stuff you could avoid reading because we brought you right back to the place where you need to be. All right, that's it. Arc Max.
That's it.
Well,
Once everything's perfectly organized, I'll start working on my thesis.
first, let's talk about the journey and what led you to today.
Honestly, it was a whirlwind because we woke up one day and thought, are we about to go out of business? Because everyone kept talking about how AI was going to change everything. The browser was going to disappear, the search engine was going to disappear. And so we were kind of scared, honestly. We kind of scrambled and thought, we got to do something fast. And again, what we found was the technology was expensive, it was unreliable, it was slow. And so we stopped altogether. But something didn't feel quite right because the technology is real, the breakthroughs are real. And so we ended up realizing is just because it's not going to boil the ocean doesn't mean it can't make your day on the internet a little bit better, a little bit faster. And we went back to the drawing board, and I'm really proud of the features we're announcing today.
Scared, going out of business, I probably would have stopped, but yet you continued. How and why?
Yeah, do you like spell check?
Actually, yeah.
Oh, my voice just cracked. You like spell check. I thank you to whoever invented spell check. It's this miraculous piece of software that just makes these little moments in your day better. And so what we realize is we can be skeptical, we can be wary of the hype, but that doesn't mean we can't find these little moments where we can save you a click, save you a couple minutes. And so that's what we did.
You mentioned small, little. So how do you take those next steps to, or do you want to go larger?
I mean, little to who? You know, I was on vacation with my in-laws recently, and my sister-in-law, who has 4 kids, was about to board a long flight. And she turns to me and she goes, Josh, if I can just have 10 minutes on this flight to myself, I will be so happy. And so the way we think about it is if we can give you a couple clicks back, a couple little minutes back and seconds here and there, like that's not small, that's huge. That is what software should do for you, and that's what we try to do.
Now, this dilemma about introduction of generative AI capabilities into existing systems is one that most developers are going to face in the future going forward, or have already been facing, like through the past year, after the introduction of ChatGPT. Previously I had a client who wanted me to integrate like a ChatGPT chatbot into the web app so that users could easily search for, could easily get access to actions within the dashboard. And I think this is something that a lot of us developers are probably going to face. So it would be nice if you had like a design pattern you could follow, something similar to the design patterns you already have, like dependency injection or factories, or the builder pattern, or the prototype pattern, or the singleton pattern. Like these blueprints that you can follow in order to, that will help you integrate certain levels of functionality into your existing software without having to like rewrite the entire code base around just a signal, instead of having to rewrite the entire code base around just a single feature introduction that you're not even sure if all your users will embrace. So basically, that's what formed. So basically, that's why I set out to try and find a useful pattern that can that is language agnostic, that you can carry over to your current project at work, and just adapt it into your existing system and see results without having to redo your entire code base around generative AI and all that cool stuff that is happening right now. So initially it was like, I'm going to build a library to achieve all this, to help you integrate with all this new functionality. But then I realized all the complexity that came with that, because the use cases were so broad, and it's not possible to just fit that into an NPM package that everyone can download. Yeah, it's like it would be overwhelming to do that. And also, since the use cases are so broad, like that fits, that's the definition of a pattern. Like when everyone has like a different problem they're trying to solve, but all these different problems can be solved by following by adhering to, let's say, a single theme. Yeah, so I think that's my definition of a design pattern. I'm not sure about the actual dictionary definition. Yeah, but based on that, I set out to try and build this pattern for so so I didn't actually start out like dedicated to work on solving like this pattern issue at first. I was actually working on a separate application which I was thinking about adding those generative AI capabilities, like borrowing from like that Microsoft video that I'd watched like a couple of months back. So like just giving the user the ability to say what they want to be done in the application. So just within the application domain, and have that like happen for that user. So let's say in a to-do list application, the user can go and like type into like this chat interface. The user can type something like let's say I just finished watching this cool series on Netflix, and it has a really great like design theme and all that. I love how all the colors are laid out. Now I want to develop a design system from that on Figma. You see, something like that, something really broad. And then this AI tool can go ahead and start creating all those tasks for this user without them having to explicitly define the different steps they need to go to in order to, let's say, create that design system. Yeah. So, like, enable, like giving the user like that much power just from any arbitrary sentence. Let's say, like any arbitrary sentence can be used to drive a generative AI tool that can run these complex actions on your backend, like doing stuff that the user may probably not have anticipated, and then returning like really good results. Yeah, so I was building a separate app, and then I just ran into that problem. Then like that's when I looked back on like the Microsoft video, like just went through all the different chunks, especially that last presentation which talks about the Power Virtual Agents. And through that I started working on this system that I'm going to explain in more detail in the next section. So after a few days of work, I come up with a system called prompt execution machine. Um, okay, which is which is a term that I totally made up. So um, I'm willing to take in any names. Anyway, the basis of it was these one, two, three, four different components. So the components begin with these are four different components which are meant to fit into each other, like pieces of a puzzle, and each of them is dependent on the next. So basically, the most basic building block is the connector. So the connector is where the actual functionality you want to be executed will be placed in. The connector itself can handle anything from stuff like passing data to, let's say, creating an object in your database, or um, sending a notification, like a push notification to your user. And then next there is on top of the connector, there is an execution manager. So an execution manager is like the definition of like a pipeline. So basically, you have an execution manager, which can be the parent of multiple connectors, and these connectors will uh, return the results to the execution manager, and then the execution manager is a child of the decider, and the decider will control which execution managers can complete a specific task. So a decider will receive input from the user and then decide which execution pipeline to take. So there can be an execution manager for, let's say, creating events on the calendar, and another execution manager for creating events on Notion. And then when the user requests that, the user may send an arbitrary request to, let's say, your application. So your application, all interactions with your current application go through the principal, and then the principal will derive tasks from all those user requests, and then hand them over to the decider, and then the decider can then choose between all the different execution managers. So like from the previous example where we have creating events on the calendar and creative events on Notion, what would happen would be, let's say the user says, I have a meeting with my design team later at 2 p.m. So that's probably a meeting that needs to be created on the user's Google Calendar. So what will happen is the decider will then look at all the execution managers it has access to. So that it has access to the Notion execution manager the and the events execution manager, and then it just reads the description of both execution managers and then says, hey, this is for this task to be completed, I'll need to use the events execution manager. So none of this has none of this logic for choosing between which one needs to be done like statically. It can all be decided by the AI itself. Yeah. So like you can have an arbitrary number of execution managers, and these execution managers will then execute a sequence of steps through the connectors. Yeah. So that's those are the basic components of the pattern. So yeah. So PEM is an acronym for like a prompt execution machine, which is what I defined it. And then the components are the principal, the decider, the execution manager, and connectors. And these form a dependent component system, allowing you to insert complex LLM driven functionality into your application. And yeah, just like the example that I gave before. And also, I only developed this because I was working on, I only developed this from the use case I was working on. So it may be different and may need to be modified based on what you're trying to achieve. So an overview would just using a normal example where, let's say, um, somebody has an assistant and they tell the assistant, hey, could you add a meeting to my calendar for tomorrow morning and set a reminder? So, like, the assistant is probably a human, and the human would be like, would know exactly what the user needs to be done, and will click through some buttons, type some stuff on the Google Calendar, and then the meeting has been created. So basically, you're going through a series of different tasks in order to complete the request. So these processes can be broken down into like 3 separate stages. There's like the inception phase where you become aware of the task. This is when you're told of what needs to uh, get done. And next is the decision phase, where you then decide on the appropriate action to take. Am I going to open Google Calendar, or am I gonna open Notion, or am I gonna open Jira? Like, this is the decision phase. And then there's the execution phase where you go, like, once you've opened, let's say, Google Calendar, there's a set of steps you need to take in order to um, create an event. Yeah, and give it a duration and like do all that complex stuff. Yeah, so turns out large language models like GPT-4, you can achieve something similar, obviously with while still adding in the connectors that I'm gonna explain in more detail later. The only caveat here is you have to really modularize stuff and be very descriptive and strict about what you need to get done. And yeah, the last part is you obviously need to know how to like work with strings, because the requests coming from the user are strings, the responses coming from the LLM are strings. So like just knowing how your way around strings is really good. This is whichever language you're working with, doesn't really matter. Okay, so as mentioned above, we have the principal, the decider, the execution manager, and a bunch of connectors. So the principal is like the main monitor of execution pipelines, and they're responsible. So the principal is basically responsible for this phase, the inception phase, like knowing, learning about what tasks need to be executed. So in my actual implementations that I'll show later, what happens is the principal will break down the user's request into a bunch of tasks. And once it has those tasks, it then passes those tasks to a decider. Yeah, so this is the interface, and I mean the principal. And this is just a basic interface of how a principal could look like. And depending on your use case, this will probably vary, but for my use case, this is what I found useful, where we have the principal interface, and it has like a property of tasks and an init function which will take care of that inception phase that I keep on mentioning, where it takes in the message, the request from the user, and then derives all these tasks from that message, fills them into tasks, and then execute, which will run all those tasks through a decider. So next we have the decider, which is responsible for the decision phase, which is the decision phase is basically deciding on what execution manager to run. So Notice here execution managers and execution pipelines are like used synonymously. So an execution pipeline is just a combination of different connectors that achieve like a specific that can be used to process a specific like task. So that's like an execution pipeline. So the execution pipeline basically means what that basically means is, let's say we have connector A. So connector A is like the entry connector. It receives data directly from the user, and then from the data it has received, it returns a result and passes that result over to connector B. And then if there's connector C, connector D, it just goes on and on, like passing, each connector passes its results to the next connector. And uh, they all complement each other in that what connector A passes down to connector B is what connector B required to complete its task, and connector B cannot come before connector A. Yeah, so it's just a one-way pipeline for processing the request from the user, and I'll probably show more code on that. So this is basically an interface for the decider, where it has the decision, which is a variable holding the current decision that has been made. A decision is just like, okay, for my use case, the decision is just the specific execution manager that has been chosen. There's the decide function, which will take in a task passed down by the principal and then decide on it. And once it is decided on it, it writes its decision to the decision here. Yeah, and then there's the run function, which now executes the execution manager. And then there's the task. This is just to hold what the principal has passed down. And yeah, now execution manager is going to be like an array of all the different execution managers you have. You may have an execution manager for creating tasks on Notion, an execution manager for creating tasks on Google Calendar, an execution manager for creating like sending some stuff over on Slack or whatever you need execution managers. So like any number of execution managers, and these are what we'll be looking at to find, like based on the decision, we'll be looking at, like the decision will be a name of one of the execution managers. So the decision may be Notion execution manager. So we are giving the LLM like a request with some data, and then asking it which of these execution managers can complete this task successfully according to the descriptions we have provided. And then based on the result from the decider, we choose one of the execution managers in this array. Yeah. So then there's the execution manager, takes in connectors. So it will take, okay, well, where were we? We're just going through the decider. Now we are on the execution manager itself. So the execution manager will have a manager name, which is the name of the execution manager, and a description. So you'd have the name like Notion execution manager, and a description like can create tasks on Notion. And then we have what's this? Yeah, and then we have the execution manager abstract class that implements the execution manager. Yeah, so this is just to define like a constructor that can initialize the connectors, like an array of all the connectors for that specific execution manager. So the constructor will take in the description and the name, the description, and an ordered list of all the connectors. It's important here that all the connectors are in an ordered list, since they'll be executing one after the other, and the results of, let's say, like I described earlier, the results of A feed into B, results of B feed into, so that one, to maintain that one way pipeline balance. And then there's the execute function. In the execute function is when we now run over the different connectors. Yeah. So lastly, the last building block is now the connectors. And the connectors, so here it's just gonna be, as you can tell from this signature, it's just a function. So it's just a function, takes in data and then returns a result. So yeah, so those are the four basic building blocks. So we have the principal, like at the top of the hierarchy, the decider, and then an arbitrary number of execution managers, and each execution manager with any number of connectors. Yeah. And now for the coding part. So I found that the best way to define this entire structure is to start from the bottom up. So basically we start from what we are most familiar with, which is connectors. And connectors are simply functions that execute specific, like do something specific. So it may be writing to a database or whatever you need it to do. So here we're going to start with a parser connector. So this is for, like, as I said, my use case where we are creating like a task list for the user. So basically, we have the task parser connector. It just implements the function signature shown earlier. So it receives the task from it receives the task when the execution manager is called. Like, the execution manager will pass, since it's the first connector in the pipeline. The input to the first connector in the pipeline will always come from the execution manager. So the execution manager will pass the task into the task parser connector, and then the task parser connector can now take that task, which is a string of user input, through this process where it's so like here it asks an LLM to pass the task, and then it provides the task, which is a string, and then like a Zod schema of the actual task. And then the expected results of this are the AI will respond with like based on the task. Like, a task can be let's say creates, let me see, okay, I'm losing something over here. The task can be anything arbitrary, like go to the supermarket. So when we ask the AI to format go to the supermarket as this task here, it will generate a name from that, a description from that, like just those words, like go to the supermarket. It will generate a name, description. If we don't provide the date, as I'll show you later, there is a way we specify. It's just some simple prompt engineering to tell it what exactly we want into this object. Yeah, so basically, we tell the AI to generate like a JSON passable string of what we want. And I'm probably just gonna go over to that section so it's easier for you to yeah. So this function here, ask LLM to pass task, is this over here. So this is just it enlarged. So it takes in the task and the schema. These are both strings, and then it asks GPT-4. Like, this is just a normal way to call GPT-4. So it passes in this custom prompt where we're specifying that, yes, I'm a bot and I have a task and its details that I would like to pass into an object I can use. Your response should, so you have to be very descriptive and like very strict. So you say your response should follow this formatting where you mark the beginning with the message for the bot, mark the end with this, and then here's the third schema for this, the result I need, and we pass in the schema, which is basically just this. So this is this, which is this over here. So this string over here. Yeah. So that schema gets passed in there, and then we now go and specify how we want all these different fields to be passed. So we say, while converting user's prompt to a JSON object, ensure it's human readable and makes sense. Then we specify how we want the name property to look. Say the name property is the name of the task. This needs to be short but descriptive. And next we specify how the description needs to look, and how the date, if the user specified any, needs to look, and also if we need to set a reminder. And lastly, we say here's what the users provided, and from that the name can generate for us like a JSON stringified version of the object we want, and then we just JSON.pass it, and just scroll back up. We just pass it back into JSON, and then now we have an object that our application actually understands. So with that object that our application understands, so as I said earlier, everything needs to be modularized. So after this connector has finished getting the JSON object, it's done with its work. There's no need to like add in any extra stuff. After it's gotten its response, it's done with its work. It returns its result, and the result gets passed on to the next connector in the pipeline. And the next connector in the pipeline is now this. I'll share a link to the repo so you can go into more detail here. But basically, it passes it to the next connector. The next connector is this function here, which takes in the task that was like that JSON object that has been passed, and then like it creates it. So here, this is substitutable for like any functionality you want, like creating it in a database or interacting with another API or something. Yeah, so it's an arbitrary section. Yeah, but for my use case, all I did was just write it to disk. Yeah. And yeah, just like that, a new task has been created. So as I said, we're starting from the bottom level going up. Now next we have the execution managers. And while defining the execution manager, we need to give it a name, and then a really descriptive description saying what exactly it can do. So for my example here, I'm saying can create a new task for the user. So this is especially useful on the decider's part, because the decider is the one which is choosing which of these execution managers to run. So that's why you need to be really descriptive over here. And then next we pass in, we now pass in the connectors in sequence. So we first start with the parser connector, which I described earlier, and the parser connector will, the results of the parser connector are then fed into the task creator. Yeah. And then the task creator is the end of our pipeline. But this is just for my use case and just for simplicity, but you could chain as many connectors as you'd like. And then in the execute function, the execute function, we now define how we are now executing those connectors. So the connectors are executed in sequence. So the functionality here is similar to like an array.reduce, where you just in order to like pass down the results of, let's say, A down to B, B down to C. In order to achieve that functionality, I had to use something similar to like array.reduce. So this reduce function just runs over the connectors I have specified, and then passes in the arguments from the last connector. So this async reduce is defined over here. So it's basically a function takes in an array of all the connectors and an initial value, and then for each of the connector functions, it passes each of those connector functions down to the async reducer, and the async reducer simply awaits for the current function to finish, and then gets the return results and puts the return results into this accumulated result, so that the next connector function can receive the results of the previous one. Hope you understand that. So it's just a simple function, not too many moving pieces to it. And then after the execution manager, we now have the decider. Now the decider's job is to choose which of the execution managers are we gonna run. So so it has let's say an array of execution managers. So these are just gonna be an array of basically execution managers like this. So this is task create execution manager, or it could be Notion task create execution manager, and then you could have another one called Google Calendar task execution manager, and all of these can then get passed into this execution managers array. So these are getting passed in the constructor. So we're just passing in the task execution manager, and then we are running the decide function. So the decide function will receive the task that comes in from its principal. So the principal is its parent, and the principal says, hey, you have this task to execute. So doing that simply means the principal is calling task decider.decide, passing in the task, which is a string, and then based on that task, the execution manager the decider now compiles a list of all the different execution managers it has and their description. So that's basically what's happening over here. And then it passes that over to an LLM to ask it which is the best execution manager that can complete the task that my user has specified. So the code for this is over here. So here we just similar strict rules as I've shown before for the passing section. We are saying I'm an AI bot, I have a task that I need to complete, and I have a list of my submodules that can complete that task. For your responses, follow this formatting. Mark the beginning with this. So mark with this. This is just the string, the string wizardry we need to do in order to get the results we actually want, just to separate it from any random stuff that GPT might have thought of. And then we tell it where it needs to place its choice, how it needs to format it. And then next we say I have the following executable submodules. Each of them can complete a very specific set of tasks. So here we specify now all the managers, and then we say my user provided me with the following task to complete. So let it choose which one to work with. And then the results of this function will be the execution manager we want to use. So that's what gets taken into this decision. So this saved into this decision. So once that's done, once you have decided on what execution manager we're going to be working with, we then use the run function. And the run function is just going to filter through all the different execution managers by name, and then find the execution manager whose name matches the decision. And with that, we have an execution manager valid to complete this task. And once we have that, we can just pass the task into the execution manager and let it run its pipeline and return a response, and then return the response the response now goes back to the caller of this run function, which is basically the principal. So after the decider, we now have the principal. So the principal simply has two functions and one property. The property is the tasks. So these are the list of all the tasks that the principal needs to execute. And in order to generate this list, the principal has the init function. The init function takes the input that comes directly from the user, which is a message like, let's say, I want to go, let's say, I have a meeting with somebody at like 3 p.m. Yeah, takes that as a message and then breaks down request to task. Yeah, so just as this function name describes, so breaks down the request to tasks, and that functionality gets handled over here. So similar prompt where we specify the like how the response should start, how it should end, what needs to be included, how it needs to be formatted, like all those details. So basically, I'm an AI bot. My user has sent me a request, and I need to pass it into an actionable list of tasks to execute. The response should follow this formatting, specify how we want the formatting to be shown, and while converting the request to a list of actionable tasks, follow the following rules. Yeah, so specify your rules like as many as you want, and then here is the user's request. So you pass in the request, and then yeah. Pass it through just some string wizardry to get what we actually want. So out of that, we get like a list of tasks, and we load those tasks into the task principal's property tasks. And after we've run that, we then execute all the tasks. So executing all the tasks, we just initialize a decider, which we described earlier, and then we loop over all the different tasks we have, and then we decide on them. So we tell the decider to decide on this task. The decider decides that this execution manager is the one that can run this task. And then we say decider.run, and then the decider now runs that execution pipeline and returns the results. Yeah. And we could add that to an array of execution results and then let the user know how the results look. Yeah, so I think that completes that process. Next, I'm gonna demo this working in action. Yeah, and now for the demo, I'm gonna start with the code and the prompts that I provided. Yeah, so basically here I'm initializing the principal. So just the task principal. This is the same code as I've been taking you through. So if you just clone the repo, you'll get the same stuff. So basically, I initialize the principal, and then I call principal.init, passing the prompt that the user provides, and then principal.execute to run all that code. So the expected result of this function is it will create tasks in, let me just clear this out, in this tasks folder. Yeah, already it's created some, but let me just clear these out. Actually, let me create, just to show you the modularity, let's go to the connectors, go to the task creator connector, and then say that instead of creating it in tasks, it will create it in, let's say, a directory called cool tasks. Yeah, let me just create that real quick so we don't have any issues in the code. And let's call it cool tasks. Yeah. Okay, so it will create them in cool tasks. And let's see. I want them to be like organized in ascending order. Is it ascending or descending? Starting. Yeah. Yeah, so let's use that, and then can go back to the code here. Yeah. So here I'm just providing an arbitrary string. Yes, I'm saying I just finished watching Hilda the Netflix animation, and I really love the design system. I would like to create a Figma design system from that someday. Yeah, so things to note, I didn't specify. Okay, let's not dig into the details about how my prompt looks. Let's just run this and see what it does. So I created a script. I just added like a simple script to execute this. It's just over here. If I run dev, it will ts node esm source index. Index is this. Yeah, so there is no magic behind it. So I'm just gonna write pnpm dev, and you're gonna see through the process. So the first step, okay, it's gonna just give it a sec. So first, now this is the principal.init. Principal.init decides on different tasks. So now the principal init has read this string here, and then the AI has said, these are the tasks that need to be done. So the task number 1 is research the animation design, a description of the task. Task 2 is analyze elements, a description of the analysis. And task 3, create a mood board. Task 4, create a design system, a description of all of that. And then next on the decider is now choosing from its provided execution managers. For now, we only have a single execution manager, which is the task create execution manager. So it decides on that one, and then it now goes through the pipeline provided by that execution manager. So it creates this, and then since it's a loop for all those 4 items, it goes through the same process repeatedly. So just doing the same thing, and then okay, yeah, this may sometimes happen due to the way the response may be formatted. So you know how JSON has all these crazy issues, like if you have a trailing comma, it's not valid JSON, and all those issues. But for now, I'm gonna ignore this. Yeah, if I run it again, it will work. It may work. It's dependent on the output. Like the output from the LLM itself is non-deterministic, so we can't really tell what it will output. But yeah, it's still something like I'm trying to figure out. But yeah, let me just take you through the task that we created. So it managed to create 2 without issue. So this is the first one. Yeah, so this is the first task. So like research. So you see it's valid JSON, which we can then send over to a database and just update fields for name, description, and date and reminder. And then the next task, something similar. Yeah. So that's really cool. And okay. So just to prove like the output is not deterministic, so it may pass on the next trial, it may fail on a different side. Like the output isn't always the same. It's never the same. So let's see what gets generated here. Yeah, and another thing I found was the time it takes to load is also it's not deterministic. We can say it will take only 2 seconds. Okay, let's see. Okay, yeah, you're still struggling with the output here. Let's try again. Maybe it will work on the 3rd try. Yeah, probably need some better error handling to prevent those kinds of errors. But this was just put together in a few days. So yes, maybe okay. This is just failing. I'm gonna go with maybe a simpler prompt. See if that works. Just a single prompt. Let's see if that one works. So there are a number of prompts that I was working on. Let me go with a simpler one. Like yeah, this is pretty simple. It's just a single task. Let's see if it executes that correctly. yeah, that was, that worked. So yeah, it's gonna be the last one. So basically, buy groceries reminder, later tonight, and also I also like passed in like the current date so that it could tell like relative times. Like if the user says today, tomorrow, in the evening, relative to what? Now I did provide a way for it to. So just within the prompt, I provided the ISO string for like the current UTC timestamp, and it can generate those dates of that. And the code for that is just over. Let's see. This is under deciders, managers, connectors. It's under the parsers, so connectors, and then let's see. We just lower this. You have ask LLM to parse. Let's go to definition. And I did provide the timestamp so that it could tell what values are that values are relative to. So doing it in TypeScript is one thing, but can it translate to like a different language? So I'm gonna explore my implementation in C# in the next section. So building out the pattern in TypeScript is pretty easy, but then my actual like application logic sits in like a .NET application. So I decided to test it out in like just a basic console app, where I tried to marry the needs of my current application, which require writing to Notion and reading from Notion and like that entire process into and then added in like that pattern. So all the code for like the pattern sits under this folder, and first we start with the lib, which basically defines like it's just copy paste from TypeScript to, okay, not exactly copy paste, but like just translating from TypeScript to C#, like pretty easily, except for a few changes I needed to make, which were the connectors my connectors got converted into classes with a run method, and then I also I also found that I need to somehow pass in let's say like context, something similar to like what you have in let's say in request handlers, where you have context passed into uh, like the request callback function. And so something similar. So I basically needed to pass down context of, let's say, the clients and all that stuff. So that's how the connectors changed. The deciders and execution managers, and the principle like stayed the same. Nothing much changed for those other three. But then there were changes to the connectors, and then introduction of context, which is not really it's simply an object that gets passed in as a parameter for like something similar to prop drilling. I could have implemented it with. I don't really think I could have implemented it with dependency injection. I tried, but I didn't really understand how to do it. Anyway, basically, what I'm trying to get at is I've translated the same pattern into like some C# code with the connectors defined here with a custom with a run method, which is where the execution logic for each connector will be contained. And then we have next we have the execution manager, and so there's the execution manager abstract class with a constructor taking name description, just similar to the TypeScript version, and then connectors, an arbitrary number of connectors. And also has a execute function. And after the execution manager, we have the decider. Decider has just similar to the TypeScript version, the decision. that it arrived at, the decide method, the run method, and then a list of all the execution managers it has access to. And then lastly, there's the principal, which is the parental ancestor of all the others, having the list of tasks, an init method, and an execute method. Now, the actual implementations for all these interfaces are within this consumers file, where we have first the connectors. We have the pass connector, which takes in the task, which is basically a string of what to do, and then takes it through like this prompt, specifying how we want the AI to respond to our request. And then once we get the results from that, we just some string manipulation similar to what we had in the TypeScript version. So here, we like what's the word? Deserialize. Yeah, we deserialize from the string to a custom defined type for like how we want everything to be structured: the name, the description, date, reminder, status, and the list of categories. These two are just tied to the application logic I'm trying to implement, so that's why they're there. But the others are just the same as the TypeScript version. And then what else do we have? The task parser. So and then the task creator, which is also a connector, and just takes in the task that has been passed from like the task parser, and then it writes it. It actually creates it on, let's say in my use case, it's creating it on Notion. So yeah, it takes it, creates it on Notion, and then above that we have the managers. So we have the task execution manager, which has a description and a name, a description, and the different tasks, the parser and the creator. And then it has an execute function which will run. So I still define like similar utilities for like async reduce. So that's this async reduce is basically here. Let's scroll down to here. Async reduce takes in the connectors, loops over the connectors, calls async reducer, and then passes the results to the next connector. So similar to what we had previously. Yeah, and then the execute function. Yeah, that's what I've just been describing. Sorry about that. And then if there's a result or if there's no result, I haven't done a lot of like error handling and all that stuff. I have defined like custom classes for the different errors, but haven't got to like handling the errors. I just following the happy path along. So yeah. Next we have the decider. So we have the task decider. It has a list of the different execution managers over here. And then it has the current decision, a string. It has the task that has been assigned. I couldn't use task because task is like the name of what's it? If something is async, it's a task in C# or something. Yeah, and so I have a task decider. Yeah, I just prefixed it with actually that's not what I was trying to get at. Anyway, here we have, yes, so basically this is the constructor, and then in the constructor we are adding the execution managers we have. So I'm adding the task execution manager to this execution managers list over here. And then setting up the client, which is now the OpenAI client. Yeah, this could all have been done with like some form of dependency injection. I just couldn't set it up on like a console application, maybe on the web API. And next we have the decide. Decide, just similar to the TypeScript version, takes in a string with the task, and then creates a list of all the managers and their description, and then passes that list then into the prompt. So just similar to the TypeScript version. And then once you're done, we have a response. So just clean up the response, like just deal with the strings so we get what we need exactly. And then there's once we have the decision, we then run a specific execution manager. So this is just filtering through the execution managers we have and getting the one we have decided on by name. And once we have an execution manager to work with, we can then run the execute on that manager, and then pass in the assigned task as well as context, which I just described earlier, like just context of stuff like clients and let's say things like constants that need to be passed between different functions at different levels. Then above the decider, we have the principal. And the principal, similar to the TypeScript version, has the message that's coming in from the user, a list of different tasks, and the only difference here is the client, which I just have to initialize like inline over here. Probably set up some dependency injection with like the web API version. And then we have the init function takes in the message, passes it through like this prompt, and defines a list of different tasks. So it's just like after this call to OpenAI, the rest of this is just string manipulation to get all the tasks. Once it's done, we can then execute. So during execute, you are looping over the different tasks in the task array, like tasks with, and then we decide on which one, get the result. If we need the result, pass it over to the execution results array and return that. So basically, I've taken you through the different components I've defined earlier. So basically, first we saw the TypeScript version. Now we've seen the implementations in C#, in C#, and now it's time to see if it actually works. So so I'm gonna demo that in the next section. So now it's time to try everything out. So basically, this is similar to the TypeScript version where we have principal.init and passing our prompt and then execute. And here we're just passing in the context that I described earlier. My use case requires that I pass in the database ID, so that's what this is. And you won't have access to it even if you try, so don't. I think, so here the prompt is simply saying, I'm mostly done with creating the tasks. So just describing what I'm currently doing. I'm mostly done creating the AI agent design pattern, but I need to document and get a site up later. I probably didn't spell that correctly, but let's see how the AI deals with that. So I'm just going to run this, and you'll see those tasks being added to this database here. So the cool thing about Notion, it will add them in real time. So hopefully that works. Let me just run this. Okay. Here this decided on task execution manager. You can see the tasks. And that means at least one of them has been created. Let's just go through the entire process of creating them. So it's complete. So they should come in like pretty fast once I press over here. So just wait, where are they? Let's see. Is this correct database? Let me just check real quick. Okay, I think it created on a different one. Okay, let me just clear this one out and let's see if it creates them here. I'm not sure which one it's using right now. Let's see if it creates them here. Let me run again. Yeah, I'll probably revoke this one after I'm done. Let's see. Here it goes. It's creating them now. And that's the second one created. And the third one is going to be created just right now. Yeah, third one's created. Yeah, everything's created successfully. And we have all of them added to our Notion, and we can see this is create a site application, document AI design pattern. Yeah, this have completed complete AI agent pattern. Yeah, there's still a couple of stuff that needs to be done. Yeah, and then like it goes ahead and like categorizes all of that stuff for us. Yeah, adds it to the backlog, and that's cool. Yeah, but now the next part I wanted to take you through is like a really cool thing about C# is a really cool thing about Visual Studio is we can like debug, like add breakpoints that enable us to like walk through the code as it runs. So we can see all the values, all the different values. So that's what I'm gonna go through in the next section, just to help you better understand what's going on. Yeah, so I've gone ahead and added some breakpoints at like some points that I think that's a key, mostly after the responses from the AI. Yeah, so I'm basically we're gonna walk through the code as it executes for all these different tasks that have been created, how it's actually creating the tasks and all that. So let me just run this. Yeah, then we're gonna hit our first breakpoints in like 10 seconds. Yeah, so we hit our first breakpoint. So this is right after we have this is what's happening here. This is what? Yeah, so we are now generating the different tasks. So now the tasks have been generated and they're now available. So they should be available here. Yeah, so basically I can open this up. Yeah, so we can see how the AI now formats its responses based on the script rules that we defined. So we defined how it should like place everything within message, like this delimiters. Yeah, and now it creates two different tasks. Yeah, so basing off this, you already know that two tasks are gonna appear here. Yeah, but now let's see. Let's just go through it like really slow. So we're gonna start with the first task, then we go to the second one. Yeah, just sequentially. So let's close that. So now we have